Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about question bank on water and its treatment. So this first question is, what is hardness of water? Explain the terms temporary and permanent hardness of water. So what is the meaning of hardness of water? So when we treat it with soap, it doesn't produce lather. So when we treat it with soap, soap means it is a sodium or potassium salts of high molecular fatty acids. So here soap, when we treat it with soap, it doesn't produce lather, is called hard water. So here, why this water doesn't produce lather? Because it's present dissolved salts of bicarbonates, sulfates, chlorides of calcium, magnesium salts. So calcium, magnesium ions of bicarbonates, chlorides, sulfate, nitrates, etc. present in water. So that's why this water, when we treat it with soap, it doesn't produce lather. So soap is a higher fatty acid such as stearic acid or oleic acid. So here for example, stearic acid for formula C17H35COOH. This is the formula of stearic acid. So soap formula C17H35COONA. Sodium or potassium salts of high molecular weight fatty acids like stearic acid or oleic acid is called soap. So when we treat it with soap, it doesn't produce lather. So that water is called hardness of water. So why this water doesn't produce lather? Because it presents dissolved salts of calcium, magnesium ions of bicarbonates, chlorides, sulfates, etc. present in water. So that's why when we treat it with soap, it doesn't produce lather. So here, whereas the soap is mixed with hard water, so the sodium stearate reacts with calcium or magnesium salts which are present in water. So the sodium stearate is the soap formula. So when we treated with this hot water with soap, sodium stearate, so your sodium stearate or soap reacts with hardness causing ions like calcium or magnesium salts and forms calcium stearate or magnesium stearate. So as a precipitate. So and which is insoluble. So that's why it doesn't produce lather. It forms insoluble precipitates. So it does not give lather with soap. So you see the reaction. This is a sodium stearate, that means it is a soap formula. So when it is treated with hard water, so in this hard water it presents calcium or magnesium ions present in that water. So it forms calcium stearate or magnesium stearate insoluble precipitates form. That's why it doesn't produce lather. What are the types of hardness of water? So already we know that there are two types of hardness of water, temporary hardness and permanent hardness. So what is the meaning of temporary hardness? So here the water, it consists of or presence of calcium, magnesium, bicarbonate in water. So this water is considered as temporary hardness of water. So the presence of magnesium and calcium bicarbonates in water, so makes it temporarily hard. So in this case, the hardness in water can be removed by boiling. So temporary hardness mainly caused by due to the presence of calcium, magnesium, bicarbonates present in water. So this temporary hardness we can remove by boiling. So the temporary hardness causing salts generally soluble in water. So during boiling process, the soluble precipitates, that means soluble sodium, calcium or magnesium bicarbonates converted into insoluble precipitates. So it can be removed by filtration. So here when we boil water, the soluble salts of calcium bicarbonate, if in case in that water temporary hardness causing salts, that is for example calcium bicarbonate present in water, so it converted to calcium carbonate. Calcium bicarbonate during boiling process is converted to insoluble calcium carbonate, which is insoluble and hence gets precipitated and it's removed by filtration. So after filtration, the water we get it is soft water. That means we can remove temporary hardness causing ions which are present in water by boiling. So the temporary hardness can be easily removed by boiling. So here soluble bicarbonates are converted into insoluble carbonates. Soluble bicarbonates are converted into insoluble carbonates. So that means which are removed by filtration. So what are the reaction takes place during boiling process? So generally in water, it's present calcium or magnesium bicarbonates in this temporary hardness of water. It containing calcium or magnesium bicarbonate. These are dissolved in water, soluble in water. So during heating process, so this soluble calcium bicarbonate converted into insoluble calcium carbonate precipitate, or otherwise magnesium bicarbonate during heating process, it converted to magnesium hydroxide precipitates. So it can be removed by filtration. So in this way we can remove the temporary hardness of water, temporary hardness causing ions which are present in water. So it can be removed by boiling. Next, permanent hardness of water. So when the soluble salts of magnesium and calcium are present in the form of chlorides and sulfides in water. So simply say we says permanent hard water means calcium magnesium ions of chloride sulfides present in water. So that water is considered as permanent hard water. So when we treat it with soap, it doesn't produce lather because its presence of calcium, magnesium ions of chloride, sulfides, etc. present in water. But this permanent hardness we cannot remove by boiling. We cannot remove by boiling. So we can, this type of permanent hardness we can remove by using some chemical methods. So we can remove this hardness by treating the water with washing soda. Treating the water with washing soda. So insoluble carbonates are formed when soda reacts with the sulfide and chloride salts of calcium and magnesium. So thus the hard water is converted to soft water. So here soda means formed by sodium carbonate. If in case in this water, that means permanent hard water, generally it's present calcium, magnesium ions of chlorides, sulfates, etc. For example, in this water is present calcium chloride. So when we are adding soda, washing soda, sodium carbonate, so it converted to calcium carbonate precipitates. So in this permanent hardness we cannot remove by boiling, but it can be removed by adding some chemical methods like washing soda. And next second question is, explain the determination of hardness of water by complexometric method. So here, what is the use of this complexometric method, or it is also called as EDTA method. So here EDTA method or complexometric method mainly used for the estimation of hardness of water or determination of hardness or estimation of hardness of water by using the EDTA or complexometric method. Here EDTA acts as a complexing agent. That means it forms complex with hardness causing ions which are present in water. So here hardness of water is determined by the EDTA method, so which involves the complexometric titration. So here EDTA is a strong complexing agent. EDTA acts as a strong complexing agent. So here EDTA abbreviation is ethylene diamine tetraestic acid. Ethylene diamine tetraestic acid. So it is a strong complexing agent whose structure is given as, so here as such it not very soluble in water, it is highly insoluble in water. And disodium salt of EDTA used in complexometry. So your abbreviation of EDTA is ethylene diamine tetraestic acid. It acts as a strong complexing agent. It is mainly used for estimation of hardness of water. This is the structure of EDTA. So ethylene. CH2, CH2. Diamine, NH2. Here NH2, NH2 groups. And tetra means 4. Acetic acid. So CH2, COOH. So carbon valency is 4. So that's why we are arranging here CH2, 3, 4 here. So this is structure of EDTA. It is mainly used for estimation of hardness of water. Next, determination of hardness of water by EDTA method. So in this case, what is the main principle involved in that? So here, the determination of hardness is carried out by titrating water sample with sodium salt of ethylene diamine tetraacetic acid or EDTA. So here using indicator is aerochrome black tea. Aerochrome black tea as a indicator. So in keeping the pH, the water here we are maintaining pH ranges 8 to 10. So here the end point is a change in color from wine red to blue. So when the EDTA solution complexes with calcium magnesium salt completely. This is the principle involved in this EDTA method. So first, what is the reaction? Here first one is hard water. So in this hard water means it's present calcium magnesium salts. So this hardness of water treated with the EBT, that means we are adding 1 or 2 drops of EBT indicator in this water sample. And also we are using buffer. What purpose we are using buffer? To maintaining pH ranges 8 to 10. Maintaining pH ranges 8 to 10. So at this pH range only, EDTA forms complex with hardness causing ions. So that's why we are using here buffer solution. So this hard water, when we are adding indicator, EBT indicator 2 or 3 drops. So in this case it forms calcium EBT or magnesium EBT complex is formed. So the color of the solution is wine red color. See this image. The color of the solution is wine red color. So first we are taking hard water in this conical flask. Next we will add 2 to 3 drops of EBT and buffer. Buffer mainly used for to maintain the pH. So the color of the solution is wine red. So the color of the solution is wine red color. That means calcium or magnesium EBT complex is formed, but it is highly unstable complex. So the next this solution is titrated against EDTA from the burette. So in this case it forms calcium EDTA or magnesium EDTA stable complex is formed, and the color changes to wine red to blue color. So that blue color indicates free indicator EBT. So this is the principle involved in this EDTA method. Next we'll discuss procedure. So here first preparation of solutions. So this EDTA method, estimation of hardness of water by EDTA method. In this purpose we are using chemicals are EDTA solution, standard hard water, EBT indicator and buffer solution. So EDTA solution, how can you prepare EDTA? So 4 grams of EDTA powder weigh out by using this weighing machine. So weigh out 4 grams of EDTA powder by using weighing machine and transfer it into the standard flask or volumetric flask, 1000 ml standard flask. So 4 grams of EDTA powder taken in this 1000 ml volumetric flask, and it is all dissolved by adding distilled water. 1000 ml of distilled water. So 1000 ml we measured by using this measuring jar. So how can you prepare EDTA solution? So 4 grams of EDTA powder dissolved in 1000 ml of distilled water. And next one is standard hard water. So in standard hard water means we are preparing some molarity of this water. So that purpose we are adding 1 gram of calcium carbonate. So 1 gram of calcium carbonate and few drops of HCl dissolved in 1000 ml of distilled water. So this is the preparation of standard hard water. Next EBT indicator. So 0.5 grams of EBT powder dissolved in 100 ml of alcohol. Next one is buffer solution. So here we are maintaining pH range is 8 to 10. So that purpose we are using buffer combination is ammonium chloride and ammonium hydroxide buffer. So here 67.5 grams of ammonium chloride and 570 ml of ammonia dissolved in 1000 ml of distilled water. So this is the preparation of chemicals which are used for this in this complexometric method. Next, various steps involved in this method. So total it's involved 3 steps. So step 1 is standardization of EDTA solution. Standardization of EDTA. That means we don't know the molarity of EDTA. So we can calculate the molarity of EDTA by using standard solution. So here standard solution means known concentration of solution. So here rinse and fill the burette with EDTA solution. So this burette filled with EDTA solution, and in the conical flask we are taking hard water sample 20 ml, hard water and 5 ml buffer and 2 to 3 drops of EBT. So the color of the solution is wine red. So here how can we calculate the EDTA, standardization of EDTA? So first clean the burette and fill the EDTA solution in the burette. And next pipette out 20 ml of standard hard water. So already we know the molarity of the standard hard water. So here that molarity is 0.01 m. So the standard hard water taken in conical flask. Next we'll add 5 ml buffer solution and 3 drops of EBT indicator in the same conical flask here. So then color of the solution is wine red. So when titrate against EDTA from the burette dropwise, so in this case the color changes to wine red to blue. So that blue color indicates the end point, that let the volume of EDTA consumed be here XML. Let the volume used by XML, or let the volume of EDTA consumed be XML. So here what is the formula we are using here? M1V1 equals M2V2. So M1V1 related to hard water and M2V2 related to EDTA. So here M1 means molarity of standard hard water. Its value is 0.01 m. And V1 is the mole volume of standard hard water. How much we put out here? 20 ml. And next M2 is the molarity of standard EDTA. So we don't know that value. We have to find out. So put the question mark. And next V2 is the volume of EDTA. So it is a burette reading. Theoretically its value is XML. So we can substitute these values in this formula. So what is the formula? M1V1 equals M2V2. So M2 equals, we have to find out this molarity of EDTA. So M2 equal M1V1 by V2. So M1 means molarity of hard water is 0.01 and V1 is the volume of water sample. We have to pipette out 20 ml by V2. Burette reading EDTA consumed be XML. So it's equal dash M. So in this way we have to calculate the molarity of EDTA by using standard hard water. This is a step 1. Next step 2 is determination of total hardness. So total hardness means it's present temporary hardness causing salts and permanent hardness causing salts. So what are the temporary hardness causing salts? Calcium, magnesium ions of bicarbonates. But permanent hardness causing salts, calcium, magnesium ions of chlorides, sulfates, etc. So in this step 2 we can calculate the total hardness of given water sample. So here also same, rinse the burette and fill with EDTA solution. Burette filled with EDTA solution. And pipette out 20 ml of sample water, given sample water. You have to pipette out in conical flask. And add 5 ml of buffer solution and 2 to 3 drops of EBT, aerochrome black tea indicator in the same conical flask. So here the color is wine red. So when titrate this solution against EDTA from the burette, the color changes to wine red to blue color. So let the volume used by Y ml. Let the volume of ETA consumed be Y ml. So here formula is M2V2 equal M3V3. So M2V2 related to EDTA and M3V3 related to given hard water sample. Given hard water sample. So here M2 means molarity of EDTA. So already we find out in step 1. So its value is step 1. And V2 is the volume of EDTA. So it's equal Y ml. Theoretically it is Y ml. And M3 means molarity of given water sample or sample hard water. So we have to find out the molarity of given sample water. So it is equal, put the question mark, we have to find out. Next V3 equal volume of sample hot water, it's equal 20 ml. So here M3 equal, what is the formula? M2V2 by V3. So here M2 means molarity of ETA. So from step 1 value we have to take here, and V2 is the volume of EDTA. Its value is Y ml by V3 sample hard water. How much ml we have to put out? 20. So it's equal dash M. Next, in this case we have to calculate the molarity of given hard water sample. So after that we have to calculate the total hardness. So what is the formula? How can we calculate the total hardness? M3 into 100 into 1000. M3 means molarity of given water sample. 100 means a molecular weight of calcium carbonate. And total makeup solution is 1 liter. So here we are taking 1 liter. So it's equal dash ppm. So in this way we have to calculate the total hardness of given water sample. This is step 2. Next, step 3. Determination of permanent hardness of water. So permanent hardness of water means we can remove the temporary hardness. So how can you remove temporary hardness of given water? By boiling. So during boiling process, temporary hardness causing salts are converted into insoluble precipitates. It can be removed by filtration. So here that purpose, what is the procedure? Take 100 ml of sample water in 250 ml beaker. So boil it to remove temporary hardness causing salts which are present in water. So after that we can cool at room temperature and filter through filter paper and to remove insoluble salts present in that water. And next, make up the volume to the original 100 ml by adding distilled water. That means first you have to take 100 ml of sample hot water in conical flask or beaker. Boil it 10 to 15 minutes or 20 minutes. Here during boiling process, temporary hardness causing salts converted into precipitates, insoluble precipitates. So it can be removed by filtration by using filter papers. So the remaining water make up by adding distilled water to 100 ml. So that water we have to take only 20 ml. Now this prepared 100 ml water we have to pipette out only 20 ml. 20 ml of this solution pipette out into the conical flask and add 5 ml of buffer solution and 2 to 3 drops of indicator. So titrate with EDTA solution from the burette. The color changes to wine red to blue. So that blue color indicates the volume of EDTA consumed here in this step is ZmL. So what is the formula we are using in this purpose? M2V2 equal M4V4. So M2V2 related to EDTA and M4V4 related to permanent hard water. Permanent hard water. So here M2 means molarity of EDTA. Its value is step 1. And V2 is the volume of EDTA. Here ZmL in this step. Volume of EDTA is ZmL. And M4 is the molarity of permanent hard water. We have to find out. So put the question mark. And V4 volume of permanent hard water. It's equal to 20 ml. So what is the formula? We have to calculate here M4 equal M2V2 by V4. So M2 means step 1 value and V2 is the volume of heat consumed with ZML and V4 volume of permanent hot water is 20 ml. So after substitution we get dash M, molarity of permanent hot water. We have to calculate in this way. Next we'll calculate the permanent hardness of water. So what is the formula? Permanent hardness equal M4 into 100 into 1000. Here M4 means molarity of permanent hot water and 100 means calcium carbonate molecular weight. So all the hardness concepts we can convert it into calcium carbonate. So that's why we are taking 100 because it makes calculation is very easy. And total makeup solution is 1000 ml. So it's equal dash ppm. So in this way you can calculate the permanent hardness of water by EDTA method. So next how can you calculate the temporary hardness of water? So temporary hardness equal total hardness minus permanent hardness. So it's equal dash ppm. So in this way we can calculate the total hardness, permanent hardness and temporary hardness of given water by using EDTA method. And next question is what are requisites of drinking water? Explain about coagulation and filtration in treatment methods of potable water. So first, what is the meaning of potable water? What is the requisites of drinking water? Water is specification. So potable water means the water free from contaminants or water that is safe for human consumption is called potable water. So here, what are the specifications of potable water? According to WHO, World Health Organization and ICMR, Indian Council of Medical Research. So according to WHO and ICMR, they are giving some specification to this drinking water or potable water. So according to that, it should be clear, colorless, odorless. It should be cool and pleasant taste. It should be free from harmful bacteria and suspended impurities. And it should be free from dissolved gases like carbon dioxide, hydrogen sulfide, ammonia, etc. And poisonous materials like lead, arsenic, manganese, etc. So the hardness should be less than 500 ppm and the chloride content less than 250 ppm and fluoride content less than 1.5 ppm and the total dissolved solid should be less than 500 ppm and pH of this potable water is 6.5 to 8.5. So this water is considered as potable water. So here raw water, that means it containing some impurities, or for example main source of this raw water is ponds, rivers, lakes, etc. So before this, generally this water collected by municipalities, they are supplied for our domestic usage purpose. But this water containing so many impurities, floating materials, papers, leaves, etc. So before they are supplied, they have to purify it, they have to treat it. So that is called potable water treatment. After that, it converted to drinking water, which is free from all the contaminant. So this is considered as potable water. So what are the steps involved in this treatment of potable water? So in this treatment of water for drinking purpose, mainly it includes the removal of suspended impurities and colloidal impurities and harmful pathogenic bacteria. So we can remove, so that purpose it's involved 6 steps. So what is the main source of water is rivers, lakes, ponds, etc. So this water is collected by municipalities, they are supplied for our domestic usage purpose. So but before they supply, they have to purify it. So in that treatment of potable water, what are the steps involved in that? Screening, aeration, sedimentation, coagulation, filtration and disinfection. So there are steps involved in this treatment of potable water. So what is screening? So here these are the screeners. The water is passed through the screens. So generally these screens are having large number of holes. So it retains floating impurities like wood pieces, leaves, heavier objects, etc. We can remove in this cleaning process. Next one is aeration. So the water is then subjected to aeration. Aeration means mixing air or reacting with air. So which helps in exchange of gases between water and air. So increases the oxygen content and removes the impurities like iron, manganese and dissolved gases like hydrogen sulfide, carbon dioxide, ammonia which are present in water. So simply we say aeration means reacts with air. Next step is sedimentation. So in this process, sedimentation means this water passes through the large stable tank. Do not disturb for 2 to 6 hours without any disturbance. So here 75% of suspended or colloidal impurities are settled down at bottom of this tank due to gravity or gravitational force. See this image, clearly observe that this water passed in this tank or beaker. Do not disturb for few hours. So in this case, all the heavy objects settle down at bottom of this beaker or tank. So say in this process, we can remove 75% of suspended impurities or colloidal impurities. We can remove by sedimentation process. Next one is coagulation. So here coagulants like alum, sodium aluminate and aluminum sulfate etc. added. So in this case which produces gelatinous precipitates. These are called flocks. So flocks helps to accumulation of colloidal particles. So resulting in setting of colloidal particles. So when we are adding coagulants in this water, it forms flocks. So it attracts the colloidal impurities which are present in this water. And next one is filtration. So this process is mainly helps to removal of the colloidal and suspended impurities which are not removed by sedimentation process. So usually we are using sand filters. This filtration purpose we are using sand filters. So in this filtration, fine sand layer on the top supported by coarse sand layer which is supported by gravel. These are arranged like this way, gravel bed, coarse bed. So this filters mainly used for removal of colloidal and suspended impurities which are present in water which are not settled down by sedimentation process. And next one is disinfection of water by sterilization. So disinfection, that means destroy the harmful bacteria which are present in water. This is called sterilization or disinfection. So this disinfection purpose we are using two chemicals. One is ozone and another one is chlorine. So these two are called disinfectants. So if you are adding ozone, so already we know that ozone is a powerful disinfectant and readily absorbed by water. So ozone is highly unstable and breaks down to give nascent oxygen. So ozone, when it is mixed with water, it is highly unstable or decomposed into oxygen and nascent oxygen. So this nascent oxygen is powerful oxidizing agent and reacts with bacteria and kill the bacteria. But what is the disadvantage? This process is costly and cannot be used for large scale because due to unstable of ozone cannot be stored for long time. This is the main disadvantage of ozonization. And next one is by chlorination. So the process of adding chlorine to water is called chlorination. So here, if you are adding chlorine different forms, that is chlorine gas, chloramine combination, or bleaching powder combination, we are adding in water. For example, if you are adding chlorine in the form of chlorine gas. So already we know that chlorine acts as a powerful disinfectant. So when we are adding in this water, chlorine reacts with water then gives hypochlorous acid and byproduct is HCl. So this hypochlorous acid is the most powerful disinfectant than chlorine. So it reacts with bacteria and kill the bacteria. And this hypochlorous acid also decompose to give HCl and nascent oxygen. So this nascent oxygen and hypochlorous acid, it reacts with bacteria which are present in water and kill the bacteria. So these two are acts as a powerful disinfectants. If you are adding chlorine in the form of chloramine combination, so that means chlorine and ammonia both are taking in 2:1 ratio. So here chlorine and ammonia both are taking 2:1 ratio, it forms chloramine. So this chloramine reacts with water, then gives hypochlorous acid. So already we know that hypochlorous acid or nascent oxygen acts as a powerful disinfectant. And next, if in case chlorine added in the form of bleaching powder. So here also bleaching powder formula is calcium hypochlorate CaOCl2. So when we are adding this water, it produces calcium hydroxide and chlorine. So this chlorine reacts with water and then produce hypochlorous acid. So if we are adding chlorine in the form of chloramine, chlorine gas or bleaching powder. So all the three cases it produces hypochlorous acid and nascent oxygen. So this hypochlorous acid or nascent oxygen reacts with bacteria and kill the bacteria. That means it acts as a most powerful disinfectants. Kill the bacteria. So in this session we'll learn about what are the important questions involved in this water and its treatment. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.